The next position in the Edit Mode toolbar is shared by the Shear tool and the Two-Sphere tool. Here we are discussing the characteristics and use of the Shear tool with the Two-Sphere tool covered in the next video. In Blender, the Shear tool is designed to push parallel elements past one another. Elements above an imaginary plane move in one direction, while those below that plane move in the opposite direction. We can see the effect here as we use the Shear tool on the elements of a cube. The location of that imaginary plane is also affected by pivot point location as set in the Transform Pivot Point panel. Here we can see how the shear effect changes when we switch the pivot point to the 3D cursor. But by far the most common use of the Shear tool is to adjust the angle of a face without creating unwanted distortion in other elements. In this situation, the tool is almost always used in conjunction with the Extrude tool, which we covered in video 42. If we try to angle a face within a shape by rotating that face, we immediately run into a problem. As we can see, rotating the top face of our cube distorts other faces, making them narrower at the top. We can solve this problem using the Shear tool. With the top face of the cube selected and the pivot point set to median, we need to select the Shear tool from the toolbar. This creates the Shear tool's gizmo, which displays 3 short axis lines, though these may be difficult to see depending on the colors in the background. At the end of each line are 2 colored bars. One bar is the color of the axis to which it is attached, and the other bar is similar in color to the axis that the selected face's edges will move along as it rotates. When we drag on this second bar, the face will reshape as it rotates. Note that the set of axes used by this tool depends on the current setting in the Transform Orientation panel. The easiest way to use the tool is to start from the named viewpoint that will show the profile of the rotation. Here we have moved to front view to rotate the cube's selected face about the y-axis. As we drag on the green bar, the face rotates but also changes its own shape so as not to distort the width of any of the other faces. In the last op panel, we have the following fields. Offset specifies the distance moved by the selected elements. When rotating a single face, a value of 1 or -1 will rotate the face by exactly 45 degrees. Axis and axis ortho define the plane about which shearing takes place, but in this situation, it is perhaps easier to think of these as the axis for rotation and the direction the face moves in. Orientation defines which set of axes we are using when defining the shearing plane. We'll ignore the other 2 options in this panel. In the top left corner of the 3D viewport, we can see the offset value as we move the selected elements. The status bar shows us the following options while using the Shear tool. Control inverts the current snapping setting while the key is held down. Shift-Tab inverts the snapping setting permanently even after the shear operation is complete. Holding down Shift gives more accurate positioning by being less sensitive to mouse movement. Now, continuing with our example, with the face rotated by 45 degrees, we can activate the Extrude tool by pressing E and then an axis letter to choose the direction. By repeating the shear and extrude operations, we can create as many corners in our shape as we need. The keyboard shortcut for the Shear tool is the rather awkward combination Shift, Control, Alt, S, but you will most likely need to adjust various options in the last op panel to achieve the desired shear direction and axes set. Hence, it's much easier just to select the tool in the toolbar. Using this technique, we can easily create the walls of a room. And by using the bevel operation, we can create a more decorative shape to our skirting board. The bevel operation was covered in videos 44 and 45.